So I recently saw a video that Tyler Ramsby covered about TryHackMe backing and building this new cybersecurity AI startup. And basically the idea, and I'll just quote the exact words here, but essentially penetration testing companies today generate hundreds of millions in revenue, and we have a unique opportunity to capture the market with the data TryHackMe has. And the huge advantage that this startup idea will have here is that it will have access to the world's largest labeled data set of hacker behavior to train AI agents on. Now, I've seen a lot of back and forth on this, whether it's meant to be an AI agent to help pen testers or something else entirely, which is pretty normal for a startup in its early days. The end goal might not always be crystal clear at the moment, but the real value is in the data that they can access, right? And honestly, whatever path lets them make the most money out of this data is likely where things are going to be headed. But we can see here the mission is to build the most capable AI penetration testing agent and change how companies identify vulnerabilities. The end state is intentionally open, right? Once the agent works, we'll decide how to scale and monetize, whether as a tool for penetration testers or pen testers, or as a platform to disrupt the 2 billion penetration testing as a service market. Right, and so it's kind of on the table here whether this is going to be something that helps aspiring pen testers, helps them do their jobs easier and more efficient, or something that ultimately replaces them, right? It's kind of a roll of the dice here. And so I encourage you to watch the full video that Tyler Ramsby posted, which I'll have linked, because he goes into some of the legal and ethical questions that this kind of endeavor is posing, right, from the community. And from what it looks like, there were some feedback channels that were created. A lot of users rightfully had a lot of questions about what this means for them and their data on TryHackMe, right? And the main sentiment that's been echoed here, no pun intended, is that, and we'll get to that, but everything TryHackMe is doing is fully compliant with regulations. And I have no reason to question that. I'm not going to get into any of the legalities here. What I'm more interested in is how this actually works, right? And try to shed some light on what's actually running and being collected, right? And also how you might be able to forcefully opt your way out of this collection if you're truly determined. Now, to preface this and get some biases out of the way, I've been using TryHackMe for a long time. Let me try to see my profile here, see where I'm at. I think, I've been bumped up to top 2%. So, I mean, I'm still, I have a decent rank, right, on the platform. I learned a lot through TryHackMe. It helped me out with preparing for the OSCP exam, and I even ended up working there as a content engineer for a bit, building out defensive training and labs and so forth. And so, historically, I'm a fan of the platform, and all the people there. And so this video is just to hopefully help people understand, based on my limited visibility and research here, what's actually going on under the hood. And so it's not negative, right? I think there are actually some very exciting opportunities here. For example, collecting attacker telemetry like they're doing, and which we'll look at, could potentially turn any boot to root machine that they have on the platform into an accompanying intrusion investigation or an incident response room, right, which is something I've always wanted to see on a platform like this. You hack into one system and then you can review the telemetry and maybe go ahead and investigate it, right? And so I'm actually quite bullish on this idea and how it could, potentially improve the platform and add some additional features and really innovate here. But really, it comes down to how this telemetry is being used at the end of the day. And so I'm curious as to how this data is being recorded and what data specifically. And so we can basically treat this like a live incident response investigation, and we can hunt for malware, right? And I'm confident that, if telemetry is being shipped off from the TryHackMe VMs, then we'll be able to track it. If the information is being collected and centralized, it would have to be traversing the network somehow, right? Again, if a piece of malware is beaconing, there's almost always going to be some network activity. And so I figured the built-in attack box is probably the easiest way to find this kind of thing. So let me just figure out where to go here. I'm just going to pick like a recent room or whatever, this recommended one here, just so I can start up the attack box. And we'll just give that a second to open up for us. So again, I'm going to use the attack box here because it's this pre-configured VM that we can use, right, to sort of complete the various rooms and CTFs on TryHackMe. And so if there was going to be some kind of monitoring, device implanted here, it would probably be in the attack box. All right, so the attack box is opened up here. Now let me full screen this bad boy so we can open up in a new tab. All right, looking good. What I might want to do first is open up something like Wireshark. So again, I can capture and monitor the traffic. And so let me just try to zoom this in here a little bit. Just going to open up Wireshark just like that in a background process. And within a second, we should be able to start capturing traffic. All right. We can probably listen on any interface here, and we don't need any capture filters at the moment. I just want to start grabbing everything we can. And we're going to see a ton of stuff immediately fly by. And if we look under the protocol here, we can see a bunch of VNC traffic. And that's going to be our own connection into the attack box, right? That's just how these things kind of work, right? Especially on TryHackMe. We're connecting in over something like Apache Guacamole through a VNC connection in our web browser. And so we can easily filter that out in a moment if we need to. But what I'm going to do here is just open up a second terminal window, or actually let me just minimize this and open up a new tab here. There we go. I'm just going to run some basic commands that might be logged, right, or might be collected from whatever agent is running here. So I run who am I? I can run an nmap against, myself. Just run it with some flags there. Just kick it off. We don't even need to get the results here. So just let that run. And then we can run something like Hydra. I'll just run it with the help option here. Again, just to collect some telemetry. And so back in Wireshark, where'd it go? Let me just stop the traffic here. What we can do is go under statistics. And then if I look at the protocol hierarchy, again, we're probably going to see a ton of VNC traffic once this loads. Yeah, there we go. So we see virtual network computing and making up, about 50% of our traffic here. So let's filter that out just with a VNC here. So we're just going to filter out with a display filter here to take out any VNC traffic. And then if we look at the protocol hierarchy again, it should be a little bit more manageable. Excellent. Okay, and so what we get here is a ton of TCP traffic. We can see some HTTP going on. That might be interesting. We can see some ARP traffic, a little bit of SSH. But interestingly, we can see Kafka. Now, Apache Kafka is an open source kind of event streaming utility. It can collect, it can process, and sort of centralize the streaming of different event data on endpoints, making it a very, common kind of platform in these use cases. If you're trying to log a continuous stream of high volume information or data, it's one of the great tools for that, right? And so that's why it's kind of interesting here. I might want to filter for this. And so let me just apply this as a filter to selected here. And that's just going to search for the Kafka protocol. Looks like we have 40 packets here, which is quite interesting. Specifically, though, we might want to focus on these Kafka Produce v9 request packets here, because these appear to have some compressed records that we can decompress in Wireshark and take a look at. And when we do, it looks like we have some seemingly what appears to be some complex JSON data. And so that's something I definitely want to take a look at here. What I might want to do here is right-click on one of these requests and follow the TCP stream so we can take a look at that conversation. Now, this might take a second to run. For some reason, my attack box is running extremely slow right now. There we go. And so we won't be able to make out everything. It looks like we have some, some characters or bytes that we couldn't sort of deconstruct here, because again, it is kind of compressed data. But we can make out some interesting, fields and values here, right? We can see room code here. We can see operating system type Linux. We can see, where was it? I thought I saw. But, oh, here we go. We can see we have reference to who am I. So I ran the who am I command, and we can see reference to that in this packet here. What else can we see? We see nmap, right? So these different packets here in this conversation are all highlighting some potentially interesting piece of telemetry here that we're being captured. And so let me go over to the decompress records here, and I'm just going to right-click on this data, and I'm going to copy it over to ASCII text. And now what I can do is paste it into something like CyberChef, and then look for the JSON beautify operation here and drag that into my recipe. And now we're getting a nice sort of a beautified version, I guess you could say, or a cleaned up syntax highlighted version of our JSON data. And so let me actually just open this up in a proper code editor here. So here we go. Again, it appears to be a JSON object that contains all the telemetry for that process that we created just by running something like nmap, right? And so you can see here the event type is set to command. So it appears to be capturing like command executions or, again, process executions. We can see things like the process ID, in my case, 3622, the parent process ID, which was bash. We can see the username that ran it. So it was root, right? We can see the process name was bash. We can see the host name, and so this refers to my actual attack box host name, right? So we saw that when we were looking at my terminal. We can see the message type is set to execve. And so on Linux, this is sort of a system call that the kernel uses to start a new program, in which case the path of that executable was /user/bin/nmap. And we can see the current working directory, we ran that from my desktop. And we can see the argument vectors here, or argv, refers to the entire command line invocation, right? And so we can see nmap, we can see the IP address that I pointed it over to, along with any of the commands that I included with that nmap command. We can see things, of course, like a timestamp. And then we get into some identifying information, right? So we see the user ID. So this actually maps over to my TryHackMe user ID. And in fact, if I copy this value, I don't know if there's a better way to showcase this, but if I were to just, I don't think it shows it here, but if I were to open up like my network tab here and refresh my profile page, I should be able to find where it's grabbing my actual user account. We're gonna see, again, some more JSON data here, what it looks like. And if I search for that string, we can see my ID is sort of matched here, right? So that ID that was from my telemetry here is mapping over to my user account on TryHackMe, right? And then the room ID, I assume that just refers to the room that I'm currently working on TryHackMe, or in this case, based on the room code, it appears to be Kali, which is sort of an internal room that just refers to the attack box, I believe, is how that works. We can also get the IP address information as well. And then interestingly, you can see categories at the bottom here. It looks like we have some MITRE IDs. So again, I ran the nmap command, and so that seemingly mapped that over to T1046 for network services scanning. We can see successful. So there was, I guess my attempt there was successful. It didn't have any typos or whatever. But we can see other categories here too, right? Like I'm conducting a port scan. I'm conducting port scanning, right? So quite interesting pieces of telemetry, all from that one command that I ran on the system. And so these are being logged, right? And they're being shipped off. If I were to go back to my attack box here, those logs are being shipped off to this IP address at 172.31.66.192. And so this is a different internal IP address that appears to be a Kafka recipient server that's, again, streaming in all of that telemetry from my system, probably any other attack box or other systems in the network. Now, I saw someone bring up data anonymization and what would happen if they threw something personal like their name or some kind of PII into the terminal window on a TryHackMe VM. And so let's see what happens, right? So we're just testing out here and really just going through the motions here to see what's happening. And so let me go back to Wireshark and start collecting traffic again. So I'll just start that. So let me just echo something like my name is Elliot Alderson. Or what I could do, just try doing this in different ways, right? So I could cat out or cat in, my name is Elliot Alderson. Or I could do something like printf and see if any of that got logged to the system. So let me just stop this here. I have my Kafka protocol, and so we are sort of filtering those out. And then it looks like we have some, again, those produce v9 requests. I'm not quite familiar with what that actually means under the hood, but these appear to be the packets that we're interested in. So let me just grab one of these here. Again, I want to go to the decompress records. I'm just going to copy this as ASCII, head over to CyberChef, paste that in, grab the nicely formatted CyberChef text there, and we can take a look at this new piece of telemetry, or I guess you call it an event that was streamed over to that server. So we can see again, command, if we look at the arguments here, and so we can see, yeah, the echo command was run. We can see the argument here into echo was, my name is Elliot Alderson. So it appears, I don't know, I can't say for sure, there's no filtering going on, but anything you type there, echo out, is going to be captured, right? And so, I don't know, maybe just don't echo out personal information in the terminal, but just because someone was asking there, I figured I would demonstrate that to see that. Yeah, it looks like most processes, at least, are being logged here. I don't know if there's other methods to log things like network requests or on a Windows system, maybe things like registry changes or files being dropped, things like that. Not entirely sure. Again, I'm just sort of exploring this in real time to see what's going on. And again, we don't know if any of this will be anonymized later on in the process, right? Certainly could. But we do know that this name here was ultimately shipped off in plain text over to this Kafka endpoint. And so we don't have to stop here, right? We know that things are being logged, but we've only sort of connected that from the network telemetry, right? So if we're curious about the underlying process that's actually logging and packaging up this telemetry to send out, again, very similar to hunting for malware on a live system, we can sort of we can start mapping that network activity over to underlying processes. So what we can do here is run something like SS or netstat, whatever you prefer. And run that for any network requests that have the destination port of 9092 because, did I close it? If we open up one of these packets, they're all going to be going to the destination port of 9092. That's sort of the default Kafka port here. And so, let me open this back up. There we go. See if we have anything. Yeah, we do. Okay. So we have several connections here, again, from our local systems interface here over these different ephemeral ports going over to that Kafka server on port 9092. If you look at the process here, you can see it's called BADR or batter. You see the process ID in this case is 2505. It's very interesting, right? So this is the underlying binary that's making those connections. So I don't know if that stands for something, batter. We were talking about behavior. Maybe it's behavioral analytics, data reporting. I don't know. Maybe something like that. Some cool internal name. Who knows? But what we could do, now that we have a process ID, in this case 2505, we can run ps the process ID of that and grab things like the PID, the parent process ID, the user, and the command line arguments. And so it's running under etc /BADR and then the binary name of BADR. It looks like it's running with some config parameters, just pointing over to a rules.yaml file and also a room.config.yaml file as well. Interesting. So let's go over, or let's list out that etc batter directory. No, it's there. Oh, there's nothing in it. Interesting. Does that mean it was deleted from the file system? What can we do here? Let's run LSOF to list out the open files. And let's run that against the process ID of 2505. And if we scroll up, yes, it was deleted. Interesting. And so we do have the process here, the binary, open in memory. It's being held open because of the running process, right? But the file on disk has been deleted, and so we can't actually, well, we can, but in theory, we couldn't actually access it because it's been deleted. And the way we can access it is just from the proc directory, right? So if I run nls under proc, and then what was it, 2505? So we can access all these different properties or objects related to that process, right? Because it's still a running process, even if the underlying binary has been removed from the file system. And so what we can do here, we'll do this in a second. We can access the actual executable itself, but I want to see how this was ultimately called. Probably a service, right? And so if I were to, I'm going to do cat-out proc /2505, and what is it? C, and then C group, I believe. Yeah, there we go. So we can see, yeah, it's tied to the batter or BADR.service. So if I run a systemctl status against BADR.service, yeah, it's active and it's running. As we can see, the main process ID, again, 2505. The process that kicked it off, though, sleep 10, and so it waited 10 seconds after the operating system booted up, and then it removed everything in etc /BADR, along with all those config files as well. And what else did it do? Yeah, so it just basically removed everything right after the operating system started up, and so it's kind of this self-cleaning service, I guess you could say. So it's kind of acting like malware here, which is interesting. But again, luckily, this process is still being held open in memory. And so we can still access it through the proc directory. So again, what I can do here is run a LL here. I just want to look at 2505, where this system link is pointing to, right? And again, we can see it used to be in etc /BADR, and it's been deleted. But we can still run whatever we want against this exe file in the proc directory because it's a symbolic link to that underlying binary. And so I can run things like md5sum against that and just grab the hash value for that process in memory, right? I can cat out things like the cmd line object here. And so again, that's just going to give us the different command line options that were invoked when this binary ran. Interesting. Let's see if this log file still exists. Yeah, let's see. Nope, it does not exist. Okay. Maybe I missed that in the service. Maybe it was self-terminating as well. But what else can we do here? Well, what I can do first is just copy that binary out of proc and just save it called sus.elf. And if I run a file on sus.elf, we can see it's an ELF or an ELF 64-bit executable. What else can we do? We can run strings against it. I'm not really gonna start picking through this binary here, but I am curious. Let's try to grep for BADR. Okay, a lot of references to a GitHub repository here. Maybe I shouldn't show this, but let me hop into that home directory here. Let me make this executable. just for fun and try to execute it. Does it have a help parameter? Yes, it does. We see we can provide a config value, which we saw, a debug mode, dry run, version. Let's try version. Okay, version 0.2.2. What if we just try to run it? I don't know what it'll do if we try to run it. Debug, let's try all the options. Oh, nothing. Is there anything in the log file? Nope. Okay. Well, that's enough playing around, right? Something I saw in sort of response to some of the feedback from the community in terms of not only the Echo AI, but also just the fact that actions and telemetry is being collected here, is that they recently added the ability to turn off Echo, which assumingly powers this data collection, right? Including this BADR service here, right? And so if we turn off Echo, let's figure out how to do that. First, let me just close the attack box here, and then I'll terminate my attack box. Let me close that. I'll go back to, I'll just go to the home page here. And to turn off Echo, I think, yeah, so we have this option slider here that we can use. So if I turn that off, this Echo thing should be off now. If I go back to the room, we shouldn't see that UI in the bottom left, that annoying prompt that came up. All right, so it looks like it's off, at least for our account here. And so let me start up the attack box again and see that if we turn off Echo, does it stop collecting our telemetry? Does it stop collecting all of our commands, right? Does it maybe spin up a different version of the attack box without that service enabled, right? Is there some kind of check-in function that shuts off the collection? Well, we'll find out. So just give it a second here to start up once more. All right, so I have my new attack box spun up here. Let me open this in a new tab. And so just to confirm, we have this Echo agent turned off, right? And we did that before we spun up this new VM. I go back over here now. Let me just open up a terminal window. Zoom this in. And so let's try to just hunt for that process right away, right? So I can just do, or that service, right? Systemctl status badr.service. Ooh, still active. It still has the same configurations. We have a different process ID, obviously, this time around. But it's still active on the system and it's running. Let's do, again, a sudo ss here, tnp destination port 9092. Looks like that is still running there. Let's do, we can open up Wireshark or TCP dump. You can listen on any interface here. We can run destination port 9092 and just print that out in ASCII to see if we're getting packets returned here. So if I open up a second terminal window and run something like who am I, or yeah, who am I, should be fine. Let's see if we can find that. It's a lot harder not doing this in Wireshark, I'll admit. But I do see we have this MITRE ID of account discovery, so I'm assuming it's going to be here somewhere. We might not be able to see it. Oh, there it is. Yeah, user/bin/whoami. So it's still collecting the telemetry and sending it over to that Kafka server. And so turning off Echo did not turn off this telemetry tracking feature. It just kind of turned off the UI in the room itself for that Echo agent. So again, I don't know how much those two are interlinked, but I assume you're still collecting the data at the end of the day. And so from the TryHackMe team, at least on the Discord here, there's no way to opt out of this tracking unless you delete your account. Or is there? Here's where I might get into some trouble. But what if we just kill that process, right? Again, we have, if I go into proc, in this case, the process ID was 2456. Again, we have this process running here. And again, if I were to just ll.exe object, we can see, again, it's pointing over to that deleted file, but the process is still running in memory. And so what if we just kill it with the process ID? So I can run sudo kill with the 9 argument to perform a sig kill, basically just force the process to terminate immediately, and then just provide the process ID, in this case 2456. And so I don't know why I'm getting this error here, but that doesn't seem to be related. Because again, if I run a ps with the process ID, it looks like it no longer exists, right? If I were to list out that proc directory, that no longer exists either. So that pretty much killed the remaining, instance in memory here of that process. And so it's no longer running. And what I should have done is have Wireshark open at the same time, just so we can see where those requests stop. Actually, no, I'm still capturing. And so So if I were to just start capturing again, looking for Kafka traffic, it looks like we don't have anything. Right? Even if I open up, new processes here, run a whoami, run nmap, nothing. It's no longer recording here, and it's no longer traversing the network because that binary is no longer running. The process no longer exists. If we really wanted to be overkill here, I could hop back into the terminal and just completely block that port. So I could run sudo iptables and just basically reject anything with the destination port of 9092. And so again, I don't know why we're getting that warning message here, but now we've sort of blocked that completely at the host-based firewall level. And so is all of this, really foolproof? Sadly not. You might be thinking, okay, I just won't use the attack box, or, I never use the attack box. What's the worry here? I just use my own VM and I use the OpenVPN connection. Well, this is kind of a moot point here, and I was just sort of demonstrating for the dramatics, because from my testing, the tracking service is also enabled on each of the remote boxes, right? Like the vulnerable machines that you're hacking on TryHackMe. And so it's kind of a catch-22, right? We can't turn off the telemetry on those remote systems unless we first break into them and then turn it off and kill those processes, right? And so, maybe, the delete your account advice is the only true way around this at the moment. What I'm going to do as an example is use this box here. It's called lookup, and I'm just going to root it, right? But before I've done this, I've already rooted the machine, and so now I have sort of root level access on the underlying machine. So now what I can do is capture the traffic from this machine. If I run a whoami, you can see I'm root. The terminal's a little weird here, but no big deal. If I were to run systemctl status and then badr.service, we're going to see it's also running on this system, right? This isn't the attack box. I'm on the attack box, but I'm in a shell on this system that I've since rooted, right, with this specific IP. And so it's also running on this system. And so what I'm going to do here, it looks like it has the same parameters and everything. It's the exact same binary. I'm just going to set up some telemetry, right? I just want to capture the packets now on both the compromised system, which I'm on, and then I'm going to re-root the machine, right? So I'm going to re-attack the machine from scratch with all this telemetry being recorded and saved to a PCAP that we can then open up in something like Splunk and take a look at the raw JSON. And so what I'm going to do here is just run a TCP dump to listen on any interface where the destination port is going over to that Kafka port there, right? And I'll just save that as a file called victim kafka traffic.pcap. Excellent, so that's listening now, and it's capturing, and so we can just ignore this shell here for the moment. I'm gonna open up a new shell, and now we're just gonna attack this machine again, just like we would. But before that, we're gonna run, let's open up a new tab here. Because before that, I'm going to also capture telemetry on this attack box host as well. So exact same command, just saving it to a different PCAP file. Cool. And so this isn't going to be a full walkthrough of attacking this machine or anything, right? I'm just going to run through some basic commands here. We can run nmap sc/sv against this specific IP, see what comes back. It looks like we have an HTTP server, and if I remember correctly, we have to add that IP address to our etc host file, specifically with the domain name of lookup.thm. So let's do that there. Excellent. So now if I open up Firefox, and again, all this telemetry as we're running these different commands and doing these different interactions on the system are being recorded not only on our attack box, but also on the remote system as well. All right, so if this wants to open up eventually, we can run, lookup.thm. Great, there we go. So we have this login page. Let's just try admin. Wrong password. Root. Awesome, let's cat out root.txt. And there we go. We have rooted the box for the second time. Took a lot longer this time. But we caught all that telemetry, right? And so we are listening here. There we go. Should have that saved yet. We have the PCAP file there. Excellent. And let me kill the other one here. Perfect. And now on this, we have the attack box PCAP as well. And so let's also use SEP here to grab that remote PCAP file and save it to our attack box. Excellent. So now we have both. Yep, FTD. Exact same file. Perfect. We've copied it over. Okay, now we can do a little bit of Wireshark trickery to actually convert and sort of filter down these PCAPs to what we need, and then just extract out the JSON. And so we'll do that first with the first one here. So Wireshark, and we've already sort of pre-filtered it down to just the Kafka related protocols, and so that saves us a lot of time. But specifically, what we want to grab here is where the API version equals 9, and that's going to limit us just to those requests. And so these are the packets that we want here. We could deep dive into some of those other packets. I don't know what they were sort of holding in them, but these were the compressed ones that are of interest to us because they contain sort of that raw JSON there. And so all we need to do is just go on File here, and then I can export the packet dissections. And I can just export those out as JSON. Great, and I'll just save that over to the desktop here as ab.json for AttackBox. Now I'll do the same thing for the other PCAP file we have as well. I'll save it as victim.json, v.json. Great, so now we have both these JSON files that we can take a look at. But first what we need to do actually is sort of dissect them. Because if I were to just run JQ against, let's say, ab.json, we're going to have a compile error here. Same with the other one, just because of the way that they've sort of been extracted here. But with a clever bit of JQ here, and I'm not going to break down this entire thing here, what we're really doing here is just printing out that decoded JSON to a file. And so I'm just going to save this over to vfixed.json. So it's just kind of cleaning it up for us. And then I'll do the same thing with the AttackBox file as well. Perfect. And so now if I cat out, one of these fixed files, now we have valid JSON that we can work with and import into any kind of solution that we want here to take a better look at this. All right, and then with those PCAPs extracted, we can open up something like a Splunk server that I have here, and basically start adding or importing that JSON data into our instance so we can start working with it in a much more visual way. Let's open up the search and reporting index here and just search for the TryHackMe index. Cool, we have 89 events that were collected between the two systems. If we look at the different hosts here, again, we have our victim with 61 individual events and the attack box with 28. And so I don't know if this is how this telemetry is being sort of visualized in the back end here, but I just figured it would be interesting to sort of take a look at. Because you can see Splunk did a good job of extracting these different categories. At least it tried to. It's a little weird here. But you see things like we get the arguments, right? So I guess the names of these different fields that were extracted are kind of weird, weirdly named because of the way that the JSON data was structured. But look, we have the arguments here. They're showing us all the different command line invocations. And so this is almost just like having sysmon data, right? And so we see all the different command line options here. So we can see things like the public HTML page here that was accessed. We can see remove here was, this is part of that exploit that we ran actually. We can see the PWM command here was run. So if I do a search to filter based off of that, we can see all the different arguments that were provided. Right? See here when we change the temp ID file here to executable, we can see when we called it, we can see what it did. It ran this sort of sh subshell. It ran the ID command, which is actually mapped over to our temp file because of our path, right? So kind of very interesting to walk through the attack like this at a very high level. Why don't we go back? What I also want to take a look at are things like, okay, yeah, we have the two different room IDs, right? So this is how you can track that kind of thing. User ID, this is my TryHackMe account. Path here, see all the different paths that I was in between each of those systems. We see all the different process IDs, the parent process IDs, process names, right? What else do I want to see here? Categories is what I wanted to find. Yeah, so here we have all the different ways in which the different commands that were captured were categorized using, I guess, one of those YAML config files that we saw passed into the BADR binary. I don't know if that's how it works, but why don't we look at the top values? See T1059 here, it's the command and scripting interpreter sub-technique, or technique, I guess. We see echo, we see exploit public-facing applications, right? So that's technically what we did with that exploit there. We can see some HTTP-related data, right? So we have some success here using Mozilla, I guess maybe from my user agent. You see different application layer protocol, credential enumeration, right? Yeah, we have the user agent Hydra. So yeah, it is using user agents. That's really interesting. We have some sudo commands being run with Linux. We have this lfinder exploitation. So that's cool, right? And they actually have different categories for each service being exploited, right? So yeah, so file discovery, exploitation. So this is kind of like custom integrated. So it's kind of cool, I'm not gonna lie. Credential enumeration, redirect, port scanning, right? So all these different things we did, which are all going to correlate over to the individual commands and the command lines that we ran. And so, for example, what if we just filtered on the attack box events like this, right? And then if I create a table here, and I want to grab the timestamp, the process name, and also the argument vector here, the different arguments or command line invocations, we can start to, if we sort by this annoying field name here. It's also in this epoch timestamp, unfortunately, so we could probably do some Splunk Kung Fu here to make that more human readable, right? And so now we can start to trace this from a timeline perspective, right? So we see here bash was run, specifically running nmap here. Maybe what we can do is, what was it called? Categories? Maybe we can map the different MITRE techniques in real time. Yeah, there we go. Yeah, so this is kind of cool, right? So this is kind of the telemetry that you can start building here. As we can see, we ran nmap. We tied that over to port scanning, right? We have the different MITRE techniques here, the sub-techniques and the techniques. We ran echo here, basically change our Etsy host file. We ran Firefox, right? Different categories for Firefox, interesting. We ran our brute force attack here. For some reason, this didn't get picked up as anything, but you know, we're just running Hydra, so you think that would map over to a technique here. Yeah, and then we ran Metasploit. Looks like a cron job ran, a monthly cron job. Yeah, nanopassword.txt, ran another Hydra command. We SSH'd at the machine. Yeah, we can run through the whole attack with this sort of command line process, low-level telemetry, which is kind of interesting. Maybe a little bit out of order. Actually, looks like for some reason the timestamps dropped off. That's probably something I messed up with my command. Not a big deal. But anyways, you can see how this data might be kind of useful or interesting if you're trying to build or train a model to conduct pen tests, right? I don't know how useful some of this would be, at least in the case of this CTF, but again, at the end of the day, you know, it's, I guess that's the goal here. And so I don't really know how to end this video other than I thought this was an interesting look nonetheless. Haven't really seen anyone dig into what's actually going on under the hood. And obviously TryHackMe's not going to explain what's going on here, which they don't have to. But I'm curious as to what your thoughts are on what you think about all of this, right? Again, I think there's a lot of potential here to improve the platform, but ultimately, I think this data will also most likely be used for some reasons that people might not agree with. Because at the end of the day, we all know that we're the product at the end, right? Our data that we're creating, especially, you know, for interacting with free platforms here, right? I actually had to buy a subscription just so I could use the attack box for this long to demonstrate this, right? So I think if you're a paying customer, you should be able to opt out to this kind of thing. Like, you know, I get it. It's like we need to collect this telemetry to power things like the Echo AI, but I don't really want that. I know a lot of people don't want that, especially if you're sort of a power user on the platform. You don't really need to be interacting with an AI to help you out, right? I'd much rather figure things out on my own. That's sort of how it's always been done, especially in the sort of try harder mindset, right? But those are just my 2 cents. But hopefully you found this interesting nonetheless, and I'm going to call it here before you know, I just keep rambling on. And so have a great day, everyone.